Hello, and welcome to today's webinar on on-base security. October is Cybersecurity Awareness Month, and in this webinar, we will discuss options for securing access to various parts of your on-base solution, including disk groups, the database, app and web server settings, device registration, authentication methods, password policies, user and user group settings, overrides, security keywords, and monitoring with reporting dashboards. One of your first areas where you will configure security in your on-base solution is on the disk group files. In order for users to be able to access documents from on-base, the disk group folders have to be shared. By default, shared folders are visible to anyone on the network, which not great, right? So if you use the advanced sharing option, you can add a $sign to the end of the share name to turn it into a hidden share. Hidden shared folders will not appear when you navigate the network folders. You have to know they're there and have the proper security in order to access them. It's a security by obfuscation rather than a true limitation of access, but it's still a step up from a public share. The best practice recommendation for share and NTFS permissions is to give users or user groups the minimum level of access required to do what they need to do in on-base. Managing this access with that level of granularity does increase the administrative overhead and can be more challenging to maintain for very large and complex organizations, but it is more secure than sharing the folders with everyone. For the application server's access, if impersonation is enabled on the app server, then that account requires the permissions shown here. If impersonation is not enabled, then the identity account running the app server's application pool is what requires these permissions. Of course, users shouldn't be accessing documents directly in the disk group folders anyway. The database will not be aware of any changes, and it might throw an error when attempting to access modified files, or even worse, deleted files. But with UNC access, that possibility does exist for users to go around the system. And there's also, of course, the risk of people viewing documents directly in the folder share that they don't have the privilege to access from within on-base itself. One way to eliminate this risk is to use distributed disk services. With DDS, in place of end users and groups having direct access, the permissions to the folder shares are granted to a single user account configured to run the DDS service. It does require a license, and there is a module reference guide with the details on how to configure it. Another way to eliminate the risk of users accessing documents directly in the disk group shares is to encrypt your disk groups. With encrypted disk groups, the documents stored in on-base are encrypted on the physical disks, protecting the data even in the event of access to the storage location of the on-base disk groups. Documents that are archived in an encrypted disk group can only be opened and viewed using on-base, helping to ensure that the security controls configured in on-base cannot be circumvented. At a high level, the process of encrypting an existing disk group involves creating a new disk group configured for encryption and migrating all the documents from the old one to the new one. This also requires a license, and details on how to configure this are in the Platter Management MRG. And there are some limitations that are also detailed there, most notably two things. One, test system creation cannot access encrypted disk group files. Even if you're not pulling over any documents when you use TSC, if the system documents disk group is encrypted, this process will fail. Two, distributed disk services does not support the migration of existing disk groups to encrypted disk groups. You can still use both modules together, but DDS would need to be disabled during the migration process. The two biggest pieces of on-base are the disk group files and the database, where the metadata lives. So let's talk about database security for a minute. There are 4 accounts that come with every on-base solution built in: HSI, Viewer, HSI Core, and HSI Net. HSI has the database owner rights and is required for on-base to function. The default password can be changed, but it's a bit of a process and upgrades will reset it. The viewer account has read-only access to the database. I recommend using this account for all ODBC connections instead of HSI. Most things these days are core-based anyway, but the only functions that actually require HSI access are built into the backends of OnBase. So viewer will function perfectly fine for any ODBC connection. HSI Core and HSI Net were the accounts used to connect to core applications like the Web and Unity clients to the database in earlier versions of OnBase. As of version 18, they're no longer in use. They're legacy security, and the HSI account and ADO.NET are used instead. ADO.NET connections are configured in the Web Application Management Console, also known as WAMCON. For most of the OnBase applications that use ADO.NET, they're most easily configured during the installation process because locating the file needed to update them after the fact is sometimes difficult if you're not directly on the app server. So when the little checkbox at the end of the install process asks you if you want to open WAMCON, always say yes. It'll make your life a lot easier. If you miss the opportunity, there is an article out on the Navient blog that will guide you through the different options and help you locate that file to get it configured. I mentioned impersonation earlier, which is one of several server-side security settings to consider. So let's look at those next. If you're not familiar with impersonation, it's a way of centralizing the access rights to one account rather than opening it to all users logging into OnBase. In a secure environment, you don't necessarily want your users having direct access to some of the domain functions and server areas that OnBase needs. By using an impersonation account, you can restrict access to those functions to an account running on the server, which can also be encrypted into the registry for additional protection. Hyland recommends using impersonation for App Server, which is the authentication layer for all the core-based applications. Although the setting is available for AppNet as well, it isn't necessary to apply it there since AppNet has to go through App Server anyway to reach the OnBase resources. An identity count is another way to shift access to a server-side resource, and it refers to the account being used to run the application pool. Depending on your IIS application configurations, you may want to use impersonation or an identity count or both. Another server-side security option is the SSL certificate, which encrypts the connection to your web applications in the browser. SSL certificates are recommended for all externally facing web servers. You can also use it for internal servers if your business requires that extra level of security. Finally, a word about passwords in config files. In older versions of OnBase, these were stored in clear text by default. You could encrypt them from the command line, but you needed to know to do it. In an ideal world, users don't really have access to them anyway because they're on the server, but risk is there, clear text, so now they can be encrypted by default. There is a setting in WAMCON for the connection strings that's automatically selected every time you open the connection strings dialog box. And you have to explicitly uncheck it each time if you do not want them encrypted every time you make a change to the config file. When you enable impersonation, either at the time of install or after the fact in WAMCON, the credentials are encrypted in the registry by default. Prior to version 18, OnBase had a separate config file for the distribution service settings that included the credentials to connect to the Exchange server in clear text. That work has since been shifted to the Unity scheduler and the database. For an added level of protection, though, you can also encrypt the temporary cache files used to build the emails. This setting was also available prior to 18, but you may or may not have known about it. And note that you can also apply an auto login credential, username, and password to a user client shortcut. Those cannot be encrypted, so you might want to keep an eye on that because that could be a way for people to find a password. Sitting between the server and the end user is the device that the person is using to connect to OnBase, and there are a few ways to register those devices. For most people, this will be a workstation or a laptop. By default, the first time that machine is used to connect to OnBase, it will register itself in the database. Some machines, such as scanning stations, dip, cold, import type functions, will then need additional licensing assigned manually in the THIC client. For users logging into OnBase via a web client, the machine that gets registered here is the web server, not the end user's machine. And these workstation registration entries will pile up over time as hardware is replaced, so it's good practice to periodically delete stale entries. And just as a quick reminder, periodically, in addition to hardware changes, making a workstation register itself as new, certain patch levels can do the same thing. The code that OnBase uses to identify a machine as distinct can be changed enough by enough patches or certain specific patches or hardware changes that OnBase thinks this is a different machine, even though it's the same machine that was used before, and it'll register itself again as a new machine, but it will not carry over any special licensing that you had assigned to it previously. So you'll have to come in here and find the existing entry, delete it, and reassign those licenses to the new entry. For users with Android, iPad, iPhone, or Windows mobile devices, the mobile broker server can be configured to allow mobile device registration for users belonging to an organization's Active Directory. The basic steps are: a user submits a registration form in the device registration settings of the OnBase app on the device they are registering. The mobile broker server registration service then validates that information against Active Directory. Then it creates a device account for the user in a separate Active Directory entry, and the user receives a verification email containing a unique activation link. After the user clicks on the link, the device is activated, and the user can log into OnBase using their newly registered device. In short, unless the device is explicitly approved for access, it isn't getting in. There are several credentials that do need to be added to the mobile broker config files to support this, including email server, verification registry, and provisioning registry, usernames and passwords. The MRG does not discuss options to encrypt them, but I suspect the old command line option would work here as well. I would also like to note that while workstation registration doesn't have this specific registration option, you can configure OnBase to not allow automatic workstation registrations in config in the global client settings. This does put extra work on the DBA because they have to manually register each new workstation directly against the database, but it is an option if you need that level of security. For the user accounts themselves, there are several different types of authentication available. The simplest is local, which is simply credentials that are internal to OnBase. Active Directory Basic and Enhanced are likely the most common integrated methods today, though Basic was removed after version 18 in favor of Enhanced, which is more robust. Additional options include ADFS, IDP, LDAP, and SSO. If you currently are using an internally hosted integrated authentication method and are looking to move to the Hyland Cloud, I would consider IDP as a replacement because Hyland will not be able to access your domain controllers. Effective October 1st of this year, Microsoft retired basic authentication in Exchange Online. If you use the Mailbox Importer module, this probably impacted you. Customers using Office 365 with an on-base database lower than EP3 will need to upgrade to at least EP3 and configure the new mailbox importer settings to use open authentication. If you're not ready for this change, a one-time enablement period is available from Microsoft from now through the end of this year. That enablement period will allow your current configuration to function while you work on getting OnBase to a level compatible with OAuth. If you are struggling to get Mailbox Importer working with OAuth, the documentation from Hyland isn't entirely clear, so I'd like to take a few minutes to step through the Azure side and hopefully save you some frustration with those settings. So these steps are in an article on the Hyland community, and they are not in the MRG. So first, you'll navigate to your Azure portal, log in, and click on the Azure Active Directory button under the Azure Services heading. You'll go to the app registrations and add a new registration entry, making sure to leave the radio button set to single tenant for support account types. And then you'll go to certificates and secrets and add a new client secret. Depending on your current configuration, you might already have this part of it in place, which is great. So in that case, you want to make a note of the settings that you'll need to plug into the OnBase side, which are the tenant ID, the client ID, and the secret value. And this is where a lot of people are getting hung up. When the MRG says to enter the client secret in config, what it actually means is the secret value. If you're updating an existing configuration, remember to also update the tenant ID in config, which has tripped a couple people up too. We've had at least one customer report that they had to clear out the settings fully and start over to get it to work. So if updating them, the existing settings doesn't do it for you, you might try that. And finally, there are 2 additional settings required on the Azure side that might be new and might have tripped up some folks as well. And those are that in the API settings, MS Graph needs mail read-write permissions, and then you'll need to grant admin consent for that app registration permission. And if it's still not working after all that, reach out to Navient support for help. Okay, so back to OnBase overall. For any accounts logging into OnBase with local credentials, you can configure password policies to encourage good password setting practices. The policy settings can control the password complexity, required characters, rotation, change frequency, and how to handle lockouts on failed login attempts. In addition, you can create multiple simultaneously active policies, order them by precedence, and set a default that applies globally. You can also override the default by assigning a specific policy to a user group and prevent the password from being changed altogether on a specific user account, which is good for service accounts. There are several additional things to consider when managing security for your users and user groups, such as what should I do with the built-in manager and administrator user accounts? Who should have access to them? As a general rule, you want these accounts to belong to the built-in manager user group and not any user-created groups, because they might contain restrictions that block these admin accounts from being able to function properly. By the same token, you want to limit the users assigned to the manager group because that group should be configured to have access to the whole of OnBase. And of course, you don't want people logging in with the manager account unless strictly necessary, right? So shared accounts, do I need any? Are there times when a shared account can be useful? Well, yes, such as the manager account, right? But again, you want that to have very limited access. And it does reduce the effectiveness of the audit trail, right? If you don't know who's logged in with the account and did something, then it's difficult to to monitor changes. So also, do I want to assign users to one user group or multiple user groups? How do I want to manage my access? Multiple is fairly common, but the more user groups you have to manage with overlapping permissions, the more administrative overhead there is to maintain the proper level of access for each group. Separating the permissions out so far that you have to add a user to 50 groups is generally not a practical solution. So there's a balance to be struck. As an admin, you'll be responsible for removing old user accounts and updating user group permissions as needed. There is a user accounts report in config that you can run, which will give you some insight into things like when your users last logged in and what user groups are assigned. And you run that report in config, but you retrieve it in the client in the system documents configuration, or sys configuration reports, I believe is the doc type. And likewise, there is a report for the user groups that records all the permissions configured. That said, I would not recommend using these reports to help you identify what needs cleaning up. They're not very user-friendly. They are a good way to document your current state before you make changes, though. So running them is not necessarily a bad idea, especially if you're going to upgrade or make a major modification. So we already touched on some override capabilities in the password policies, but here I want to focus specifically on document types. Document type overrides are configured at the document type level by user group and enable you to add and remove default permissions as needed. So when using doc type overrides with multiple user groups, a user may be a member of 2 or more groups that have conflicting override privileges. And in the global client settings and config on the security tab, you can specify whether the permissions should be treated as least or most restricted in the aggregate. In other words, do I want the user to have all override permissions from each of the groups the user is in, or only the override permissions that all those groups have in common? The default setting is least. However, when a user is in a member of 2 or more groups, but override privileges are only configured for one of them, the most restricted override privilege is used. This is a perfect example of why you don't want to put the manager account in user created groups, because you don't want to nerf it accidentally. Security keywords might be considered another kind of override. Security keywords enable you to restrict access to documents by the keyword value. They can be set at the user or user group level and configured to restrict access to documents that either have a specific keyword value or those that do not. As an example, we use this feature at Navient to restrict our employees to only be able to see their own HR records. And if you want to restrict access to keyword value data, there are also options available to encrypt and hide keywords. The biggest downside to user group and override security features is that they're hard to track because the settings are spread out, making the aggregate permissions difficult to identify, and settings like the overrides and security keywords easily forgotten. And this is where reporting dashboards can be a real boon. If you have the reporting dashboards module, Navient has a bundle of what is now up to 79 reports that are designed to make critical data like this more accessible and on-base, 18 of which are focused on security settings, enabling you to access the information in a more centralized way with fewer clicks. I should note that the bundle for Oracle databases is currently at 75 reports. I'm working on getting that updated, but all the reports shown here are already included in those 75. And to show you an example, the security override reports displays the security keyword and document type override settings all on one screen, so you can easily identify what settings are impacting a user who may be a member of multiple groups. In addition to the security reports, there are also reports focused on administration to help you keep the system tuned, auditing, and other configuration settings. And you can use them to provide read-only visibility to a larger pool of users whom you don't necessarily want poking around in config. If you already have this bundle, I do make improvements to existing reports over time and have done so recently, in addition to creating the new ones. So feel free to reach out to Navient support if you want the latest copy. And that's all we have for you today. Thank you for attending this webinar. I hope it was informative. See you next time.